So let's look at sulfur dioxide now, SO2. So the electronegativity values for SO2, we know now that oxygen has an electronegativity of 3.5, right? We have that memorized. So sulfur is in the same column as oxygen. So as you go down a column, the electronegativity values decrease. It's going to be less than 3.5. Now, is it going to be ionic or covalent bonds between sulfur and oxygen? So the electronegativity value difference is actually going to be less than 1.5. You can look up the exact electronegativity value for sulfur, but it's not going to be less than 2. So since it's less than 1. The difference is going to be less than 1.5, it's going to be covalent. Okay, let's look at the number of valence electrons. So both of the oxygens each have 6 valence electrons. So the sulfur, it's in the same column. So 3 times 6 is 18 valence electrons. Okay, so is this structure going to be hypo, hyper, or octet? So this structure is actually going to be an octet structure. And we'll see in just a bit that sulfur is going to want to have an octet. Going to follow the octet rule. So either is the structure also going to have resonance? Is there going to be resonance structures? So there will actually be resonance structures. There will be 2 resonance structures. And you'll see when we draw the structure why that is. Because both of the oxygens make equal contribution, and there's going to be a double bond. So you will have resonance structure. So let's draw the 2-dimensional structure of SO2. So here, let's look. This oxygen has a formal charge of 0. 1, 2, 3, 4, 5, 6. 6 valence. So 6 minus 6 is 0. This oxygen has 1, 2, 3, 4, 5, 6, 7. 7. So it's 6 minus 7. It has a negative. We'll give it a negative formal charge. The sulfur has 1, 2, 3, 4, 5. 5. It's supposed to have 6, so we give it a positive formal charge. However, the sulfur fulfills its octet. It has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So this is an octet structure. However, you can see that both of the oxygens are equal. They make equal contribution. However, this one has double bond, so we can switch it and make the other oxygen have that double bond. So you may wonder, okay, how come we have a negative and a positive? That's okay, because the negative and the positives cancel out. So you actually have still an electron neutral molecule, right? Because positive minus cancels out. So let's look at how many electron-rich regions are there around sulfur. So there's 1, 2, 3. 3 electron-rich regions. Remember that the pi bonds, those don't count as 2. There's actually just 1 electron-rich region. So when there are 3 electron-rich regions, we call this trigonal planar. And so what kind of hybridization is trigonal planar? Well, remember the trick I told you. So if we have 3 electron-rich regions, we'll say sp2. 1 plus 2 equals 3. So the hybridization is sp2. So what is the bond angle? Well, so trigonal planar is where the atoms are arranged in a triangle fashion, like this. So you can imagine that between the bond angles are going to be about 120 degrees. However, because we have the electron unbonded electron pair, it's actually going to push the other angles to be a little bit less. So it's going to be a little bit less than 120 degrees. So how many bonding pairs of electrons are there in this structure? So let me just draw one of the resonance structures. Again. I'll just draw both of them. Okay, so how many bonding pairs are there? 1, 2, 3. 3 bonding pairs. Okay, how many unbonded pairs are there? There's 1 unbonded pair. Okay, now let's look at the three-dimensional structure. So for trigonal planar, I kind of already drew it out for you. It's going to look like this. So do you see how the three regions are arranged like a triangle? So right, the 3 sides of a triangle. 1, 2, 3. So let's make sure to write the molecular geometry. So it'll be A, B3, U1. Right, 3 unbonded pairs, 1 unbonded pair. And so let's draw. Is either going to be dipoles? Yes, there will be dipoles, right? Because there's electronegativity difference between oxygen and sulfur. And so which is going to be the more electronegative atom? The oxygens, right? So let's look at the dipoles. Let's draw it one more time. So the arrows are going to go like this because it goes towards the more electronegative atom, right? So this is a Vesper with dipoles. Now, how many sigma or pi bonds are there going to be? So the double bonds, there's going to be double bonds are considered 1 pi bond and 1 sigma bond. Okay, so how many sigma bonds do we have? We have a 1 double bond and 1 single bond. We have 2 sigma bonds. And we have 1 pi bond. Okay, remember that's important. The double bonds have 1 sigma and 1 pi. And is this molecule going to be polar? Yes, it will be polar, right? It has a net dipole.